program studi teknik sipil, teknik mesin, teknik elektro, informatika, arsitektur, dan teknologi pangan. Keunggulan yang dikembangkan di Fakultas Teknik dan Informatika sejalan dengan revolusi industri 4.0, yaitu pengembangan Internet of Things, robotik, 3D printer, dan bidang-bidang lain yang dibutuhkan di era milenial ini. Bergabunglah bersama Fakultas Teknik dan Informatika. Kami siap membina, membimbing, mengarahkan menuju masa depan yang cerah.
Nama saya Lutfi Arianto dari program studi teknik sipil Universitas FTI Semarang. Memperkenalkan bahwa program studi teknik sipil itu sangat saya banggakan di sini. Mengapa demikian? Karena program studi teknik sipil memiliki dosen yang berkompeten di bidangnya. Selain itu juga di teknik sipil memiliki alat-alat di laboratorium yang sangat lengkap. Salah satu kegiatan di lab UPGRIS adalah penelitian dengan uji beton. Kita bersama dengan dosen dan juga teman-teman dari teknik sipil, kita akan memperkenalkan apa itu uji beton, kita lihat bersama-sama. Selain uji beton, di sini juga ada uji tanah. Mahasiswa bersama dosen sering melakukan pengujian tanah dengan sampel yang tersedia di sini, lalu kita uji menggunakan alat seperti di belakang kita seperti ini. Selain praktek di laboratorium, kita juga sering praktek di lapangan. Salah satunya adalah praktek teodolit. Mari bergabung bersama kami di program studi teknik sipil Universitas PGRI Semarang.
Ternyata saya tidak salah pilih masuk ke program studi teknik mesin Universitas PGRI Semarang. Karena di sini alat-alat laboratorium sangat lengkap dan juga didukung dengan dosen-dosen yang sangat berkompeten. Di Laboratorium Teknik Mesin Universitas PGRI Semarang memiliki alat-alat seperti milling, CNC, bubut, uji tarik, uji kekerasan, serta dilengkapi dengan peralatan-peralatan lainnya. Kami juga diberikan kebebasan dalam berkreasi dan berinovasi. Dengan banyaknya kegiatan mahasiswa, di antaranya ada klub robotika, klub UAV quadcopter, dan lain sebagainya. Kuliah di Teknik Mesin Universitas PGRI Semarang memang menyenangkan. Teknik Mesin Universitas PGRI Semarang, action to move the world!
Kami dari tim KBM Informatika Universitas PGRI Semarang. Jadi udah pada tahu belum KBM itu apa? KBM itu adalah kompetisi bisnis mahasiswa Indonesia.
Jadi ceritanya, kita dapat hibah dari Kemenristek Dikti di tahun ini sebesar 14 juta rupiah di bawah bimbingan Ibu Mega Novita, salah satu dosen di Prodi Informatika Universitas PGRI Semarang.
Jadi di informatika kita akan diajarkan untuk membuat aplikasi berbasis website dan Android. Nah, selain itu kita juga akan diajarkan animasi dan juga desain grafis.
Selain itu, di sini kita juga diberi wadah sebuah informasi seputar sertifikasi di lingkup kampus maupun luar kampus yang diadakan oleh BNSP yang berkaitan tentang pembuatan website maupun Android.
Yuk gabung di Informatika Universitas PGRI Semarang. Ditunggu ya.
Di arsitektur UPGRIS kita diajarkan bagaimana mendesain dan merancang sebuah bangunan. Seperti halnya bangunan sederhana untuk rumah tinggal, bangunan pabrik, bangunan multimasa, UPGRIS building, dan yang terakhir bangunan make use.
Di
arsitektur BIS kita akan diajarkan bagaimana cara mendesain dari gambar manual hingga gambar digital. Untuk gambar digital sendiri, kita akan belajar menggunakan aplikasi AutoCAD, SketchUp, Revit, dan Lumion.
Di arsitektur UGRIS kita diajarkan untuk merancang suatu bangunan yang berkonsep green building atau ramah lingkungan dan hemat energi.
Mari bergabung bersama kami di Arsitektur Universitas PGRI Semarang, Green Building for Better Living.
Salam kolaborasi karya, salam Elektro Jaya. Saya Amin Haryanti, mahasiswa Teknik Elektro dari Universitas PGRI Semarang. Teknik Elektro Universitas PGRI Semarang tergolong baru. Namun meskipun tergolong baru, belajar di sini sangat mendapatkan fasilitas yang baik serta didampingi dosen pengampu yang berkompeten.
Selain itu, kami juga pernah mengikuti lomba kontes robot regional meliputi Jawa maupun secara nasional.
Mari bergabung bersama kami di Teknik Elektro Universitas PGRI Semarang. Salam kolaborasi karya, salam Elektro Jaya. Saya Anggun Desiana Sofa, mahasiswa Teknologi Pangan Universitas PGRI Semarang. Selama saya kuliah di Teknologi Pangan Universitas PGRI Semarang, saya banyak belajar hal baru. Saya dapat menginovasi produk yang belum ada di masyarakat, seperti ada kopi kulit pisang kepok, ada kopi beras analog, dan tepung gembili. Bergabung dengan kami di Teknologi Pangan Universitas PGRI Semarang.
Fakultas Teknik dan Informatika unggul dan berjati diri.
Oke, bismillahirrahmanirrahim. Oke, kita mulai. Bismillahirrahmanirrahim. Good day everyone. Welcome to the international webinar series held by Faculty of Engineering and Informatics, Universitas PGRI Semarang. It serves with the cooperation of Universitas PGRI Semarang Indonesia, University Technology Malaysia, and University Technology Mara Malaysia. The participants consist of several academicians, students from many countries, France, Hungary, Malaysia, Turkey, Tunisia, Czech Republic, and Indonesia, of course. For your information, this webinar series has been held 6 times with different themes. Series 1, talking about artificial intelligence. Series 2, cooling technology. Series 3, about electrospinning and nanomaterials. Series 4, talking about accreditation for the technologists and engineers in the new normal era. Series 5, about green building in new normal life. And the final series, which is today, entitled Multimedia Interactive Systems. And this event will end with the closing speech by Dean of Faculty of Engineering and Informatics, Universitas PGRI Semarang. Let me introduce myself. I'm Nora Kotronada. I am an instructor in Informatics Department, Faculty of Engineering, Universitas PGRI Semarang. I will be your moderator today. Hopefully you enjoy the discussion. And we very appreciate everyone involved in this webinar series, especially Rector of Universitas PGRI Semarang, Bapak Associate Professor Muhdi, Dean Faculty of Engineering and Informatics, Universitas PGRI Semarang, Bapak Associate Professor Slamet Supriyadi, Chairman of the Committee, Dr. Irna Fariha, keynote speaker today, Bapak Profesor Ali Slamet and Bapak Assistant Professor Febrian Murti Dewanto. All of the guest speakers who have given their excellent talks since season 1 till the final season today, who came from University Teknologi Malaysia, University Teknologi Mara, Selangor, Malaysia, and of course, Universitas PGRI Semarang. All participants who has attending continuously from series 1, 2, 3, 4, 5, or those who just attending today. Thank you very much for always supporting us. Thank you for your attention. So this webinar goes smoothly. Before we start, I will explain the rule that needs to be followed by the participant. First, all the participants must name themselves following the format: participant name _ institution name, for example, participant name _ institution name. For example, Nora Kotrun _ Upgris. Participants are advised to mute their mic to reduce the background noise, but basically the host will automatically mute them. We recommend you to turn on your camera because in the end of this event, we will have photo session. This webinar will run for about 1.5 hours. And first, the speakers will have 35 minutes to share each of their presentation and then followed by the parallel Q&A session. In the Q&A session, participants can ask either by chat in the chat room or directly you can use the raise hand option. You can deliver the question in both English or Bahasa Indonesia. Just keep it convenient. At last but not least, we will distribute the attendance form which will be used to generate the e-certificate during the Q&A session. Therefore, we request your cooperation to focus on the speakers while they give their talk. Thank you. And Alhamdulillah, we already the speakers join in this Zoom room. They are Professor Ali Slamet, Dean of Japan International Institute of Technology, University Teknologi Malaysia, and Assistant Professor Febrian Murti Dewanto, the Vice Dean of Faculty of Engineering and Informatics Universitas PGRI Semarang. Let me read their curriculum vitae. Professor Ali Slamet is a professor in software engineering at Faculty of Computing UTM. He is Dean for Malaysia Japan International Institute of Technology, University Teknologi Malaysia, UTM. He also a chair of IEEE Computer Society Malaysia section. Professor Ali was the CIO and the director of ICT UTM. He also was the Dean of Smart Digital Community Research Alliance UTM. The educational background, he received a diploma in computer science, UTM, BSc in IT from Teesside University, United Kingdom. He has received a doctor engineering degree from Osaka Prefecture University, Japan. Professor Ali Slamet is currently a visiting professor at Hradec Králové University, Czech Republic, Kagoshima Institute of Technology, Japan, and he was visiting professor at Kuwait University, Japan Universities, Universitas Islam Sultan Agung Indonesia. Semarang, right? Yeah. You already been to Semarang, Prof. Okay, next. Our second speaker, Bapak Assistant Professor Febrian Murti Dewanto. We usually call him Pak Anto. Yeah. Pak Anto is Vice Dean of Faculty of Engineering and Informatics, UGRIS. He was head of Informatics Department's Faculty of Engineering and Informatics, UGRIS, from 2014 until 2019. He was National Resource Person, Ministry of Education for IT Curricula in 2013. He is also assessor for PNSP, Indonesia National Professional Certification in Junior Programming. The educational background, Pak Anto received Bachelor Economics from Universitas Diponegoro Semarang and Master of Computer Science Universitas Dianuswantoro Semarang. Okay, for the first speaker, I will welcome Professor Ali Selamat. Thank you for joining us today. We are ready to receive your insight and sharing. And we know you are a very, very busy person, Prof. Thank you so much for being here. Okay, Professor, are you ready for the talk?
Okay, thank you very much. Yeah.
Okay, everyone, let's welcome Professor Ali Selamat. Professor,
Assalamualaikum
is yours.
and yeah, good evening to all of you. I'm trying to change the background just now, but I think I have a problem. Can you hear me?
Yes, I can hear you clearly.
Okay, that's great. Anyhow, I would like to share my screen. Yeah. Let me share my screen. Let me share my screen. I have a problem with the not be able to content. Just wait. Yeah. Okay. I'm trying to change my screen just now. Just wait for a moment. Yep. Right.
Sometimes we have to close all the windows.
Yeah. I think I need to close the windows to open up the screen. Just yep. Just wait. Can you see my screen?
Not yet, Prof.
Yep. Share screen.
Yes.
Yeah, can you see? Okay, it's good. Okay, so thank you very much, the chairperson for today's seminar. First, I would like to thank the Universitas PGRI Semarang for giving me the opportunity to share the topic that I'm going to share to all of you today, related to the detection of vulnerable plaque in a virtual histology intravascular ultrasound images. So basically, the areas that I'm going to share today is related to image processing. Yeah, and this is the work that I did with numbers of researchers that working with us in the areas of ultrasound images. And as you can see here in the bottom of the page, we have these collaborators, but I have a bit detail of these collaborators. So these are our collaborator, yeah, from different university. So we have from Czech Republic, from Japan, from Spain, yeah, from Iran, yeah, and this is the work that we work together in producing kind of research collaboration that is related to the cardiovascular image analysis. Yeah, so I believe that many of you here are familiar with these areas. Yeah, cardiovascular is one of the issues that people are actually facing, and is becoming something very important. And I'm not a medical doctor, by the way. Yeah, but I would like to just to share with you on the insight of the research that we did on this area. Okay, I think about myself already shared with you. I think the chairperson already shared about my background just now. Yeah, I already skipped this part. Yeah, and I just want to share with you that I'm presently the Dean of Malaysia Japan International Institute of Technology in Kuala Lumpur. Yeah, and for today's talk, if you want to further read the detail of it, so these are the information that you can later on check, yeah, on the related publication that we made to further enhance your understanding of this topic related to diagnosis of vulnerable plaque, yeah, and basically we talk about the geometric features and things like that, yeah. Okay, so basically, the ideas of this research is focusing very much on the coronary artery disease, yeah, and this is something very important to all of us that facing the risk of aristocratic plaque, yeah, that a kind of heart disease, yeah, and this is very important for all of us to get aware that how actually the analysis has been done using this ultrasound technologies that is called virtual histology intravascular ultrasound, yeah, that analyze the morphology of the coronary arteries. And as you can see here, this is normal, yeah, you can see that this is the left side, yeah, you can see this is the how to say that this is the figure related to the let me go to the laser pointer. Yeah. So this is the vein, yeah, of this heart, and you can see this is normal artery, yeah, nothing actually being left at the bottom of this artery when the blood flows at the artery, and then you can see the fatty streak, yeah, and then erythema plaque. Then you know when the artery is getting thinner and thinner, yeah, and this is a situation that you may see later on that indicate the size of the artery is getting smaller and smaller, and then stop the blood circulation here, yeah. So this is the issues that usually faced by the people who got the heart attack, yeah, and for this example we show that this is the progression of this atherosclerosis disease, yeah, and this is quite interesting, yeah, for you to look at. And as you can see here, this is the vulnerable plaque. So how actually it grows here in this part, is inner part, and you can see that this is a heart, the blood vessel movement, and as you can see, this is a cross-sectional flow, yeah, of this heart, and how actually those plaque is developed, yeah, from day one until certain period of time, then will be expanded and becoming a blood clot, yeah. So which means that your blood cannot move, yeah, from one direction to another direction, and it caused the heart attack, yeah. And as you can see here, this is the vulnerable plaque, yeah, and this is before, yeah. You can see that this is whereby this is the lipid core in the middle, yeah, and when you have this rupture, meaning that there is a process to you call it burn or putting some kind of device to clean up the clot here, yeah. So they call it a rupture process, yeah. And C is showing the stable plaque, yeah, and then D is the histology image corresponding to the stable plaque, yeah. So you see that this is the lipid core, yeah. So this is the ideas of the research that we are trying to work on, and basically we work with the Technical University of Munich, yeah, in Germany, in providing this type of image analysis and further strengthening on the algorithm development on the information technologies, how actually this can be done to detect the composition of this so-called plaque. Yeah. Okay, and this is the machine that is used to scan the patient and to capture the images. Yeah, and the images that I showed to you before on all this. Yeah, these images. Yeah, this one, not this one. Yeah, later on. Basically, the image is taken from this volcano eye VUS imaging system. Yeah, and this is quite advanced system that being developed to detect this intravascular blood movement. Yeah, in the blood vessel in our hearts. Yeah. And this is the work done by our collaborators, yeah, Professor Taki, yeah, Alas Taki, using those equipment that having this intravascular ultrasound and then border detection and then tissue characterization, whereby we have this polar transformation of these images, and then we have the shadow detection and then feature extraction based on the pixel in the neighborhood characterization. And then we reduce the noise of the features, yeah, and then afterwards we classify the images, yeah, and to know that this plaque is which type, yeah. So these are the processes involved, and finally we show the images in this color, yeah. You see that how is it look like? The red colors is the more typical part of the plaque that could be removed, yeah, and the green colors is it's not difficult to be removed, but still needs to have some progression of it, yeah, to remove those colors, yeah. All right, and as you can see here, we have this fibrous, yeah, the green colors, yeah, and then you have this light green, yeah, right green colors, yeah, fatty acid, yeah, this is right green, yeah, and then dense calcium, and then you have a neocratic core. And this is more vulnerable, meaning that it's very, very difficult to be removed, this part. You see the red colors, yeah? If anyone of you can see your blood circulation in your heart, then it might be scary, yeah, for us, yeah? Then this is something that is very, very difficult for us to look at. And of course, this kind of research is taken from this image, yeah, recognition system. And this is histological pathological classification scheme, yeah. They call it histopathological, yeah, history and pathology, yeah. And basically, this is the what we call as image classification that we call it pathologic intimal thickening, PIT, yeah. So this is A, yeah, the normal one, and B is quite thick, yeah. It's a fibrotic plaque. You see that a lot of red colors here, yeah, red colors, and then fibrocalcified, yeah, and this is a little bit part, but still you see the condensation of the red colors is quite high, and then fibrotrauma, yeah, thin cap fibrotrauma, yeah, TCFA. So you can see that, yeah, and then we have this thin cap fibrotrauma, thick cap fibrotrauma, and calcified thin cap fibrotrauma. So this is the THCFA, yeah. We call it TACA-TCFA, yeah. So this is the differentiation of this. And you can see there is a white color, so meaning that is much more difficult compared to the red colors, yeah. Okay, so this is the original ideas of the research that we are doing. And if you are familiar with machine learning or kind of artificial intelligence, so usually people use this machine learning at this site, yeah, k-means, yeah, fuzzy c-means or self-organizing map or fuzzy c-means or many others, yeah. And in the segmentation process, we use this boundary and region growing, graph cut, active contour. And then from the features extraction model, we use this local binary pattern, modified round length algorithm, neighboring layer level algorithm, first order statistic, wavelength features, and others. And in terms of classification, we use this technique, yeah. So we use this support vector machine, SVM, error correcting code, fuzzy rule-based, artificial neural networks, random forests, and k nearest neighbors. So these are the tools that we use to analyze these images. And from the analysis of the work, we found out there are some issues with these intravascular image segmentation. So the main problem is that the thresholding methods is not reliable for the segmentation because of the mixed tissue type in intravascular ultrasound system. And then the accurate quantification, accuratization, and the location of the plaque component. And then the automatic features extraction method is not satisfied with the classification. And then the present image processing technique did not consider all features to identify vulnerable plaque. And the other one is the subjective assessment procedure. So we need to have the evaluation to be done based on careful examination by the, as I showed to you just now, the imaging machine. And then we have the other technique related to soft computing techniques. And we also need to have an expert. Yeah, so cardiovascular expert and radiologist expert also to be in place to verify and validate the analysis that been done on the research. Yeah, and of course, finally to show the results. Yeah. So this is the research question of the research. Yeah, how to propose a new approach for accurate segmentation, feature extraction, and this feature extraction of these images based on virtual histology images, yeah, and how actually we look on this segmentation of the image, and how to detect and measure the nucleatic core in the context of lumen border, and then to extract the important features from the images, and then what kind of classifier that is the best, yeah. So this is the part of the research that we are working on, yeah. Then from there, we look at these ideas of overall issues. Then we identify the research issues related to the clustering algorithm, yeah, and then related to the combined features, yeah, to make a better classification and to extract significant features from the images just now, and then lumen border tracing for open and closed lumen, and then automated plaque classification based on the machine learning, and then assessing the IVUS characterization, yeah. And this is the overall scope of the research that we did, yeah. So data set from the visual histology images. Clustering, we use this fuzzy clustering, fuzzy C-means, yeah, K-means, and SOM, self-organizing map. And we also did this hybridization process based on the K-means and PSO, particle swarm optimization, and fuzzy C-means and PSO, particle swarm optimization. And then we use this feature extraction based on the different types of features, yeah. As you can see here, CNC, CDC, and others, and all the textual features as well. And we have these different types of classifiers as MKN, KNN, and these are our clustering results. Yeah, we use the C-Halot classification, and then we have these measures of accuracy, sensitivity, specificity, and others. And we use MATLAB for our evaluation. Yeah, and this is our research objective. Yeah, on identifying the segmentation method and to detect and measure the nucleatic core in the content of the lumen border in the image. Yeah, and then we understand this through the proposing of the algorithm based on the hybrid models. Yeah, and then propose and implement the lumen border tracing to detect the plaque in the lumen. Yeah, and then these are the proposed models that we developed. Yeah, we call it fuzzy C-means, KNN, and fuzzy C-means support with the machine to support the classification. And we look at the algorithm to support the open lumen border tracing and closed lumen border tracing, CLBT and OLBT. and to extract the significant features, to find out the accurate plug characterization, and of course to classify different plug classification types. So we are using this ensemble classifier of software machine to understand this kind of a situation. And I believe that this area is related to medical informatics, yeah, and quite challenging if we are not familiar with those terminology. Yeah, perhaps you can refer to this terminology. I think some is related to IT, like you are using machine learning on artificial neural network. Yeah, you are using the fuzzy C-means. Yeah, particle swarm optimization, and of course region of interest. Yeah, so these are the common words. Yeah, K-means and PSO. But there are some other related terminology for these areas of image processing related to medical informatics, in particular on the detecting the so-called visual histology images. So we have a CDC, confluent DC, nucleotic confluent, yeah, CNC, yeah. We have the dense calcium with in contact with the lumen, yeah, DCCL, yeah, dense calcium layering, yeah, and extracting confluent component, yeah, ECG. I think you are probably quite familiar. Electrocardiogram, yeah, and then FF is fibrofatty tissue, fibrotic tissue FI, first order, and many others, yeah. So again, we are now focusing on visual physiology and intravascular ultrasound, VHIVUS, in this research. This is already shared with you on the different part of this coronary artery plaque classification, intimal medical thickening, pathological intimal thickening. So this is the situation that you can see that only half, yeah, and you have this FT is for fibrotic plaque, yeah, and FC is for the fibrotic plaque, yeah, fibrocalcific plaque, and then you have this FA, fibrotrauma, and then this is fibrotrauma, and then you have the calcified fibrotrauma, CA, FA, yeah, and you have this TCFA, yeah. So this TCFA is something related to thick calcified fibrotrauma, yeah, and calcified TCFA, yeah. So these are the images. And these are the challenges of the detection, as you can see here, when the images, taking the images in different, what you call as angle. So you can see that this is guide wire effect, yeah. So in the middle here, and then this continuation effect from this part, yeah, and then ring down artifact. You see that this is to the middle, yeah, and then reverberation artifact is the outer layers, yeah, and then this is NURD artifact. So this is from the Cartesian, yeah, and this is the percentage of each of the classification, like fibrotic, yeah, fibrocalcified, adaptive pathological, intimal thickening, and others, yeah. So these are the classification criteria. Let's skip this one. And this is the confluent necrotic core. So you can see that this is non-confluent necrotic core with the pathological intimal thickening, yeah. And you have this confluent necrotic core with the development of a video trauma. So this is the circular mass diameter of the minimum diameter of around 12 pixels or 0.08 millimeter square, yeah, based on the 400 by 400 VHIVUS image, yeah. And when we use this Envision Gold volcanotropic software, then you can see that this is a proximal side, yeah, and then from distal, and this is the 3D study at this frame. Each frame is connected together, and you can see that this is the, let's say this is the blood circulation or blood movement. Then you see how much the angle is appeared here, yeah. So in this research, what we did is that it's related to the understanding the literatures, yeah. Then we gather the data, yeah, And then we apply soft computing technique. Either we use this semi-supervised or improved algorithm. And then we validate the data by the expert cardiologist, yeah? And then we can see the overall results of this experiment, yeah? And this is the data collection. We use these in vivo images with 10 patients, yeah? These 10 patients already being approved through this so-called ethics committee, yeah? And we received these images from our partners, universities and researchers, TUM, yeah? Technical University of Munich, yeah? So you can see that this is the virtual histology images from various types of images, yeah? And we put into classification numbers, yeah? 1 to 32, yeah? So you see that different colors representing different level of thickness of the plaque, yeah? Inside the artery, yeah? And then you can see that this is the images in the open lumen, yeah? The thickness of these images, you can see here from this side, yeah? Imagine that this is in your next to your heart, yeah, the blood circulation. So this is something very interesting to look at, yeah. And this is the composition of the image, and then from these intravascular ultrasound images, so you can see that this is representing in this way, yeah. You see that, and this is representing in this way, yeah. And of course, the same way as for these images, yeah. So you can see that it shows in this way, yeah. And the same thing like this image, yeah. You can see that how thick it is, yeah, from this side. And of course, the last image, yeah, from the A image and B image. And this is the measures of accuracies. So we do this equation, quite simple, yeah. True positive and true negative, yeah. So we calculate this accuracy, precision, recall, specificity, and of course we have this F-score. And then we segment this, and we apply this clustering algorithm, we evaluate, we optimize, and we look at what is the hybrid model that is suitable. And of course, the main issues of the clustering is that it's time consuming to cluster it if the numbers of images is very high, and the sensitive inertia of cluster numbers and cluster centers, and of course it's sensitive to noise, and it tends to be affecting this local minima. Yeah, if you're familiar with the machine learning algorithm, when it comes to the local minima, then your algorithm may be stopping at that time. Yeah, and then to merge the different two clusters. Yeah. And then we use this fuzzy C-means, yeah, and K nearest neighbor to look at this training of the images, and then for the testing of the images, and how actually we could get the result based on those algorithm that we use, yeah. And we also use this K-means PSO model. So from the image, we use this VH IVUS image, and then we process the image, and then we create the numbers of clusters. And then if the clusters is close to the centroid, then we calculate the centroid means to each others. And then after that, we input this into the K into PSO, particle swarm optimization. We calculate the fitness, evaluate the fitness, and then we understand this cluster, either this is the nucleotic core or nucleotic core and others elements of the class in the images, yeah. So this is the comparison of enhanced algorithm. So this is patient 1, patient 2, and patient 3, and we use different algorithm, KMPSO, fuzzy C means PSO, fuzzy C means KNN, fuzzy C means minimum Euclidean distance, and fuzzy C means as LVM. So this is the different classification, and you can see the result here on different patient, yeah, how much the accuracy of each of it, yeah. So as you can see, the overall is like different patient may have a different results, yeah. But more or less, I think this fuzzy C-mean support vector machine, yeah, it shows high in patient 1, but not really patient 2, patient 3, and others, yeah. And this is when we use fuzzy C-means KNN. Fuzzy C-means maximum equilibrium distance, and fuzzy C-means support vector machine. So you will see that the different results here. And it seems that fuzzy C-means minimum equilibrium distance is much higher in a way, yeah. Okay, so the finding of the first part is that we identify the strength weakness of the clustering algorithm, and then we try to look of improving the algorithm, and then we develop this segmentation model for the image, yeah, VHI VUS. And then the second part, we develop the feature extraction based on the confluent nucleotic core, yeah, CNC, and then CDC, NCCL, and others, yeah. And then on the texture features, we use the same image, yeah. And we have different types of extraction model, yeah, LBP, GLCM, and MRL. So I think I would like you to later on you can check again, yeah. So these are the nomenclature just now, as I said. And we developed this closed luminal border tracing algorithm, yeah. And the other one is we developed the identification of this CLBT, and it shows the lumen border tracing, how much that we can trace from one side to another, yeah. So this is the CLBT, and we validate it through the ImageJ statistic and also statistic, yeah. And for this patient 1, yeah. And of course, this is on the validation. And this is for the lumen border tracing, yeah, using this CLBT, yeah. And this is the overall border tracing, yeah. We need to trace the border of the lumen, yeah, based on the what they call as the images that given to us. And this is from ImageJ, so you can see that how much they're tracing. And this is OTSU, and this is a closed lumen border tracing. And of course, this is open lumen border tracing algorithm that we propose in our solution. Okay, so this is extracting different border tracing and validate using OTSU method and ImageJ software, yeah, based on the nucleotic core in contact with the lumen, and confluent nucleotic core in contact with the lumen, CN-CCL, yeah. And this is an extracting confluent component. And as you can see, this is a confluent component from the algorithm that we developed. We can detect this confluent nucleotic core, yeah, on the images that we can see here. So how to check that this is the original images or not based on these images, yeah, of A. We have these different types of image. And then we have this 339.83. So these are the images, yeah. And of course, you have this 44.12 and 38 from 12, yeah. And this is for the confluent DC, yeah. So you can see the image has been detected based on the white colors, yeah, representing the hardcore plaque, yeah. And this is nucleotic component layering, yeah. So this is the algorithm that we developed, yeah. And to identify this region of interest of this image, yeah. And then the other method is that we develop this plaque burden assessment to calculate the plaque area, yeah, the vessel region using the equation 18, yeah, in our algorithm, and then vessel areas, lumen areas, and plaque burden based on the equation 11, yeah. So this is the example that we have, and this is the plaque burden. You can see that how much the plaque burden that is being constructed here, yeah. And this is quite important. part of it. Yeah. Okay. All right. So this is the plug component features. You can see this is the differentiation, and we did this kind of labeling. Yeah. Human subjectivity labeling. Yeah. CDC, CNC. How much the percentage of it? Yeah. Based on the type of the nucleotic core just now. Yeah. PIT, TCFA, and CAT-CFA. As you see, the more the red they are, and the more the wide they are, the more difficult it's going to be removed. Yeah. In a physical way. Yeah. And then we do this local binary pattern, global gray level co-occurrence metric, yeah, to identify the features, yeah, based on the colors. And then we use also this modified run length, MRL, yeah, to check the features. And then the third objective is propose a 5 new algorithm, the features extraction. And then we do this dataset leveling, yeah, process. And then we classify and validate the data set that we have from our extraction. Yeah, we use a single classifier, a multiple classifier, and of course the other one is on the ensemble classifier. Yeah, and from there we look at this plug type, as I showed to you that multiple class plug is we use this like for the pathological intimal thickening, TCFA, yeah, later the thin cap phlebotomia, yeah, and then thin cap phlebotomia we classified TCFA, and then we also have this non-TCFA and TCFA for the binary class. So these are the different types, and this is the accuracies of the detecting those plug, yeah, based on this. CTFA is almost 100%, you can see here, yeah. Based on this feature extraction process that we made, yeah. And these are the features. You can set all features, size with 17, yeah. Feature size 1, feature size 2, feature set 3, and feature set 4. And this is the different types of features that we select. And from these features, we can see the different kind of classification, yeah. And you can see here, we use different multiple types of classifier, yeah. So this is single classifier, and if you benchmark 100, so you can see the different here, how much the accuracy, specificity, yeah, sensitivity, yep, and of course the false positive and false negative as well. And then afterwards, we also use this ensemble classifier, whereby we do the we have this feature vector. And then we do the labeling as I shown to you just now, and we do this feature selection. And afterwards, we do this separately classified, and we do the majority voting with the support vector machine, artificial neural network, and k-nearest neighbor. And then we identify either it is becoming the TCFA or non-TCFA. And this is the overall result that we produce when we use the assemble. Not much different actually compared to the normal one, but you can see some enhancement, yeah, for the betterment of the classification in a way, yeah. And we use these different types of clustering, yeah, with the PCA, principal component analysis, yeah. This is from the global local CM, yeah. So this is a part of the clustering model that we use based on the support vector machine, yeah. And of course, finally, we validate our works, yeah, through cardiologist decision, yeah. And of course, we use also machine learning, yeah, based on the images. And of course, we also have the medical doctors, the expert on the radiologists as well, yeah. So just want to recap that this is the detection of the VHI, VUS, and OCT, yeah, optical computer tomography images, yeah. So you can see that this is the images of grayscale IVUS, yeah. And then And when we see this is a VH, visual histology, intravascular ultrasound images. So this is the images. And if you are use OCT image, it's becoming like this, yeah. So in this case, we are not looking on the OCT images because we are focusing on the ultrasound images, yeah. So what we did is that we have this support with the machine, and we have this optical computer tomography images, and this is the image, and this is the image ID, and this is the classification using SBM and OCT. And later on, we have this another one is from the expert, yeah. And from there, we have this cardiologist decision and support vector machine, yeah. So this is like a CD, yeah. And of course, we have this KA is the radiologist involvement as well. So we can see that the results on accuracy with different values here, yeah. Some is 81, some 79, and 781, yeah. So in our research is actually we're trying to see that how much the accuracy if we are not using the expert, yeah. How much actually we could receive the result if we are using the expert, and how much the result that we can get if we are not using the expert on cardiologist, but the expert on radiologist. So we can see that the detection is quite interesting, yeah. And this is the, we call it CD, is the expert here. So the expert will put either 1 or 0. 1 is they agree with this decision, 0 they disagree with the decision, yeah. So this is the different images, yeah, that we have. Okay, and then I think this is the end of my sharing, yeah. So we have the research limitation of these images from the ultrasound research, yeah. So we have the visual histology in the intravascular ultrasound images. So they have a different format. So the different format might produce different results. And we have the various definition of plaque type. If you Google the VHIVUS, you will get a lot of information, but usually it comes from the medical doctor's what do you call it, explanation, yeah. Different diameters of the confront area, and then lack of appropriate samples for the plaque types, yeah. And then the other thing is non-public data set, yeah. Usually for you to do this kind of research, you need to have a big amount of data for you to do a research, yeah, especially related to heart, because it's involved the patient approval, yeah. So meaning that the research ethics has to be complied at the beginning when you start your research, yeah. Okay, in the conclusion, we have this two hybrid model that we developed for segmentation of the virtual histology and intravascular ultrasound system, yeah. And then we did different types of algorithm to show the differences of it, and we see the different values that we generate from the results, yeah. And we also use these OCT images, and we measure it through the cardiovascular expert, yeah. And of course, we also have from the machine learning, and of course from the so-called radiologist input as well. So I think that's all from my sharing. I hope that it's not that heavy for you today, yeah, in terms of the content, yeah. But I hope that it will give you some ideas of what we are doing in our research imaging on the multimedia technologies, yeah. So I hope that that's the part of my sharing. If you have any question and things like that, yeah, and this is possible for you to ask later on. Okay, I return back to the moderators, please. Yeah.
Okay, thank you, Professor Ali Slamet. Thank you for the presentation of your research about image processing of IVUS. Many medical terms that I'm not familiar. Okay, Once again, I welcome questions from participants. Just write your question in the chat room. Type your name, your institution, to whom you want to ask, and your question. Or you can ask the speakers directly, use the raise hand option. Then we will unmute your microphone. For the next speaker, I will welcome Assistant Professor Febrian Murti Dewanto. Hi, how are you, Pak Anto?
Fine, thank you.
Okay, are you ready for your talk?
Yes.
Okay, everyone, let's welcome Assistant Professor Febrian Murti Dewanto. The time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and Excellency Professor Ali Slamet, nice to meet you. Dr. Engineer from UTM and respectable Dean Faculty of Engineering and Informatics, UPRIS, and all the lecturer and all my students and audience in this webinar series. First of all, let's pray and thanks to God, Allah Subhanahu wa Ta'ala, who is giving us some mercies and blessing so we can gather in this webinar series in a good condition. So thank you so much, Mrs. Nora, moderator, giving me time to present this webinar. I'd like to deliver my presentation. Let me share my screen. Okay, can you see my screen?
Yes, Pak Anto. It's
okay.
Clear.
Wait. Okay, maybe this is more lighter than the first speaker, Professor, because I will present about the multimedia computer animation mixed reality in informatic UPRIS. This is about a course that related with multimedia interaction and system in informatic UPRIS. So I'll start with this is I skip maybe. As we know that Department of Informatics in Universitas PGRI Semarang is under the Faculty of Engineering and Informatics in Universitas PGRI Semarang. We have 6 departments as architecture, then civil engineering, mechanical engineering, electrical engineering, informatics, and food technology. So we are private university that built in 2014, so we are young and 5 years, and we try to grow more and better. And then about multimedia interactive system, today I will present about how course multimedia implement in our informatics department. So of course, the terminology for my student, always I say that multimedia is a combination of 3 elements, namely sound, image, and text. It's by McCormick in 1996. And then the multimedia is combination at least of 2 media input or output of data. This media can be audio, sound, music, animation, video, text, graphic, and image by Urban 2002. So this is not my research, but more telling story to the audience about course in informatics department in Universitas PGRI Semarang. Like, as we know that multimedia and computer vision included sound, image, and various way can be used in the business and learning. Because our university is come from Institute of Teaching and Learning, so we will be focusing on in learning. There are 2 sides of multimedia. User, the first they create the content, the feeds with computer software and links. The second is users take advantage of multimedia as a tool or mean of searching for unlimited information. So When we come to interactive media, always refers to product and service on a digital computer-based system, which respond to the user action by presenting content such as text, moving image, animation, video, audio, and video games. And then in terminology of interactive media, there's related the concept of interactive design, new media, interactivity, human-computer interaction, cyberculture, digital culture, interactive design, and include of augmented reality. The essential feature of interactive that is mutual, user and machine. It's take an active role. Most interactive computing systems are for some human purpose, interact with human in human context. Any form of interface between the end user or audience and the medium may be considered interactive. Interactive media is not limited to electronic media, digital media. It can be a board game, pop-up books, game book, flip books, and construction wheel. On the example of interactive media. But here we're talking about the interactive media based on the computer. And then let's start with what courses in informatics department in Universitas PGRI Semarang. The content of multimedia course that provided in Department of Informatics, such as, for example, we have a course for multimedia system, animation technology, and interactive multimedia. Here's the picture of our student who was a winner in regional competition about mobile programming. And the second picture will be the picture of our laboratory in Universitas PGRI Semarang. In informatic department Universitas PGRI Semarang, we try to make this framework for 21st century learning. So we combine our life and career skill, learning and innovation skill, information, media, and technology skills. And then there's a core subject for the 21st century themes. There's standard and assessment, curriculum and instruction, professional development, and learning environment. Okay, there is the multimedia interactive system inside the curricula in 2013 curricula computer science. I take it from the ACM and IEEE computer science curricula. There's many section about computer science that include algorithm, architecture and organization, computation, discrete structure, graphic and visualization, human-computer interaction, information security, information management, expert system, network and communication, operation system, distributed computation, programming language, software engineering, and information system. So we try in the Department of Informatics UPIS. The course is called the Mixed Augmented and Virtual Reality. It's under the human-computer interaction, and then there's a multimedia system under the information management, and the computer animation under the computer and computer graphic. Human-computer interaction is concerned with designing interaction between human activities and the computational system that support them, and with constructing interface to avoid this interaction. Interaction between user and computational artifact occurs at an interface that includes both software and hardware. Thus, interface design impact the software lifecycle in that it should occur early in the design and implementation of core functionality can influence the user interface for better or worse, because it deals with people as well as computational system, as knowledge area of FTI demands the consideration of cultural, social, organizational, cognitive, and perceptual issues. Consequently, it draws a variety of disciplinary traditions, including psychology, ergonomics, computer science, graphic and product design, anthropology, and engineering. So, human-computer interaction is intersection between the field of computer science, engineering, design, and of course the psychology, sociology, and ethnography. This is the sample of our student final project that using the human-computer interaction approaches. That project is, the title of project is Introduction to Musical Instrument Application with User-Centered Design Method. This final project by Lia Ayu Kusmaningrum from the graduate Department of Informatics 2019. So, she picked the user-centered design as a method for building or creating the application to make the learnability, efficiency, efficient, memorability, error, and satisfaction. And then they identify needs for human-centered design, understand and specify the content of use, specify the user organizational requirement, produce design solution, evaluate design against requirements. It's all come back to system satisfy specific user and organizational requirement. That's method from ISO 13447. It's an international standard established in 1999. The standard provides guidance on human-centered design activities throughout the life cycle of computer-based interactive system. And then the other sample of final project from our student, that's about the implementation of algorithm fisheries for creating mobile application about national. They use the quiz for shuffling, the algorithm for quiz shuffling. He's used the Fisher-Yates shuffle. It's an algorithm for generating a random permutation of unit sequence in plain from the algorithm shuffle in the sequence. The algorithm effectively puts all the elements into a head. It continually determines the next element by randomly drawing an element from the head until no element remains. The algorithm produces an unbiased permutation. Every permutation is equally likely. This sample with C# for quiz shuffling algorithm with Fisher-Yates. So in this algorithm, that the data of quiz is in the array, then there's shuffling in the Fisher-Yates shuffle algorithm. And then next, another application that final project from our student like this one is more about like educational game. There's Japanese script or Aksara Jawa, as we know, with several random question algorithm. Okay, for FTI, mixed augmented and virtual reality, we also in the course of Department Informatics, it's how to create an augmented reality. This is already in 7 or in 6 semester, and this is the example from final project. The student we create a mobile augmented reality application for Android to introduce and promote the University of PGRI Semarang building. This application is called Agris Augmented Reality, and this start and it show all the building in our campus. We have a 4 campus, all landmark building, then it show the building. This is good for the promoting our campus, our university, and landmark and building. And then because we want a more educational mobile augmented reality, so this is why to make the augmented reality in our student final project. For example, there's a systematic literature review from Its line from Department of Computer Science, Electrical and Space Engineering in Sweden that already analyzed 31 eMarts or educational mobile augmented reality games from the perspective of technology, pedagogy, and gaming. In the pedagogy, there are several eMarts focus on learning subjects that require concretization of abstract concepts, such as mathematics and physics. So PR is focused on the learning subject that require the concretization of abstract concept. These observations are aligned with previous research results, indicating that the key of pedagogical affordance of mobile augmented reality is ability to visualize abstract, invisible concept. And then there's an iterative process, need to plan properly, consider stakeholder first, who is going to use the system, what is the educational level, and how is the work of the atmosphere. This is another project from our traditional clothes and house in Indonesia. There's a project from students with using augmented reality to use in our elementary school that creating the design-based modeling from traditional clothes and house in Indonesia. This is the picture, the book, manual book that contain the traditional houses and clothes. Okay, this is pedagogy learning theory. I think I'll skip this. Behaviors, cognitive, and this is the model of instructional system design, and this is the method for multimedia. And in result of technology, in the technology, in the analysis results suggest that interaction with augmented reality content was mostly based on visualizing virtual content and using the touch screen of a mobile device to interact with the content. This is the most obvious way, given that this review focused on mobile devices. So the tool we use that in course augmented reality, we use the Vuforia and Unity. Therefore, the popularity of Vuforia SD card does not come as a surprise because it's very open source and Unity open source too, and can create the good augmented reality. There's another like Arrays, Aurasma, Blipar, and okay. Next, in courses in informatical place, we have to the base model of computer animation, to create the base model from the animation, to make that model exist in augmented reality. So the model is created by student himself. And then come to interactive media, and we can create serious games or fun game. In the computer animation, use a Blender that more like making model there's the inverse kinematic and forward kinematic model to use in games or augmented reality model. So we try to create a physics with a computer animation in a Blender too. And then we also create interactive multimedia for games. As the computer science has progressed, video game industry has implemented various computing technology concepts. The computer science has improved graphic, multiplayer games, and cloud-based and on-demand gaming, and availability of virtual and augmented reality. Okay, our game is course created with C# and Unity. The game development here is more to game for education. How to apply the model they have created in the Blender to be exported to the Unity, and then apply some the artificial intelligence technique in the game. It's like game working in our building. In video games, artificial intelligence is used to generate responsive, adaptive intelligent behavior, primarily non-player character. This is for the enemy of the NPC. Make the NPC similar to human-like intelligence. Modern game often implement existing techniques such as pathfinding. This can be a star algorithm, decision tree, and a guide to the action of NPC. So another finite state machine in games for computation based on hypothetically machine made of one or more states. If the NPC or the enemy is in the state event, then the player is idle, player is attacking, they attack, and so on. So the last from the course in interactive multimedia, especially to create the games, with the Unity machine learning again, we offers the flexible way to develop and test new artificial intelligence algorithm quickly and efficiently. There's a plugin in Unity for ML again. It's generation of robotic games and beyond. So this maybe the final project for the course interactive multimedia creating game. There is mobile and desktop or PC game. Sample our student presentation. Okay, the conclusion is we in Informatic Department in Universitas PGRI Semarang provide courses in multimedia, interactive system ranging from computer animation to make case model used to make augmented reality application to games. The role of computer science here is, of course, to develop the application that meet user demands and applying the right algorithm and tools. And in the end, our graduate student can play a role in the society that developing in a regional or national creative economy. That's my presentation. Thank you. I give back to Miss Nora.
Okay. Thank you, Pak Anto. Okay, everyone, it's time for Q&A. Once again, I welcome questions from participants. Just write your question in the chat room. Your name, type your name, your institution, to whom you want to ask, and your questions. You can also ask the speakers directly. Use the raise hand option. Then we will unmute your microphone. Okay, I will read this. To Professor Ali. Your talk is very interesting. Basic on your presentation, you did comparison of, this from Mona from Universitas PGRI Semarang. Basic on your presentation, did comparison of an enhanced algorithm. In phase 1, you found the highest is 0.97, that is KMPSO. Could you please let me know the reason why it became the highest one? Would you please, Mr. Professor Ali? Unmute.
Okay, thank you very much. I think, thank you for your question. Yeah, from I think Mona Riza. Yeah, I think let me show the screen just now that you asked on this. Yeah, we're talking about the question related to this why the result is much better for the KMPSO. As you can see, the result is higher. Yeah, KMPSO, the blue color in overall. Yeah, the reason is that you can see from the this is K-means PSO model. So we use the different numbers of clusters, and then afterwards we induce this into the PSO. Yeah. So meaning that, as you remember just now, we were talking about the local minima. Yeah. And then this local minima has been alleviated through this PSO that enable us to generate more results. If you go in deep on the KM or PSO, you will see the difference how actually those thing has been done in comparing to fuzzy C-means and others. So that's just the reason that we identified why the result is much better compared to the normal one. So I hope that will give you some answers on your question.
Okay. Okay, Mona, you may go on. Okay, Professor, maybe this is out of the topic of your research presentation, but I want to know, would you like to share us how to promote the development and ecosystem of creative industry in Malaysia? We know that there are many creative products from students, from lecturer or the others, but usually they are not yet worth selling. How to commerce that? Can you tell us or share with the condition in Malaysia?
That's quite interesting question. Yeah, about this kind of promoting the ideas of innovation from student. Yeah, either is in a software solution, or it is in a kind of virtual reality, or others solution that has been made in the lab. Yeah, but the solution in the lab usually a small scale, so there will be a process that needed to be enhanced. Yeah, so in Malaysia we encourage our students to participate in the program that being opened up by our so-called previously they call it Multimedia Development Corporation. So this is like the multimedia industries in Malaysia that supporting very much on the promoting of the new ideas, new innovation from lab to market. And the other thing is we bring the industry come to the university when we develop this solution, yeah, or this kind of product based on the final year project, for instance. So we bring numbers of industries that familiar with that kind of product, and then we ask them on is the product is viable for further enhancement in terms of values to the market and so forth. And if not, then what else that need to be needed to be add up to the product. If it is suitable, then what are the process needed for the product enhancement so that it can go towards a different level of market. Yeah. So these are the process of that we are nurturing our student. But nurturing student themselves are not sufficient. We also have a process that we allow our academics or our staff that to be attached with the industry for 1 year, maximum to 2 years. We call it they call it latihan itisas or industrial attachment. Yeah, apart from postdoctoral program and others. So this allow them to be attached with the industries that are actually in the areas of the so-called product commercialization. So they can learn how the process has been transformed from the ideas that being discussed in the classroom or the ideas that being developed by the student, and what are the other product that is needed by the industry. So we need to create this kind of ecosystem so that we can have more participative engagement from not only student, but from our staff, academic staff, and of course from the industries as strong collaborators to our product development. And this is what we are actually taking place now, apart from what is the support from the government that is developed to enhance the so-called like creative media industries, for instance. Yeah. So these are the areas that we are actually exploring, and the support from various parties are very important, but the ecosystem within the institution also need to be ready so that we can have more new ideas, new product that we can develop that suitable to the market. Yeah. So I think that's my general ideas or general experience that how actually we develop our so-called student entrepreneurs and how actually we can capture the interest of the industries as well.
Okay, thank you, Professor. But line government, industry, and university. Line string alignment.
Yes.
Thank you. Next is from user. Pak Anto, could you tell us how the student work in the laboratory during the pandemic, especially those who practice interactive multimedia? because they usually complain, students complain that their laptop or their computer tools specification are not good as in the lab. Could you, Pak Anto?
Yes, thank you, Miss Nora. I think this condition need with a solution because the regulation in Indonesia to forbid them, the student to come to laboratory because it's pandemic and very dangerous. And I think in the regulation we can see that if the final project, if that is the final project, so the student can come to the laboratory with, of course, the protocol, and then they already send the mail from the dean that they will practicing in a group or individually, and then the head of the laboratory can make a schedule for not crowded in the same laboratory. I think that's the thing that we have to create a regulation for the student can come separately different time. I think that's
Solution. Solution.
solution.
Solution is yeah. Okay. Thank you, Pak Anto. Okay. I see no, there's no question anymore. Okay, I think it's enough for the discussion. Maybe if some of you still wondering something, you can ask the speakers privately by email. My apologies, we couldn't accommodate all the questions in the YouTube, especially, yes. So we have to end this session. Thank you very much for Professor Ali and Pak Anto. Ladies and gentlemen, join me to give big applause. Of course, digital applause, of course, yes, for their insightful presentation. Okay, thank you.
Thank you, everyone.
Thank you.
Thank you.
Thank you, Professor.
Thank you, Professor. Yes. Now we have come to the closing session. With this, I would like to invite Dean of Faculty of Engineering and Informatics, Bapak Associate Professor Slamet Supriyadi. Pak Slamet, can you hear me?
Okay. Thank you, Ms. Nora.
Oh, yes.
Okay, thank you.
For being here. Everyone, let's welcome Associate Professor Slamet Supriyadi. Please, time is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon. The Honorable Dean of Malaysia Japan International Institute of Technology, University Technology Malaysia, Professor Ali Slamet, Doctor of Engineering. Nice to meet you, Professor.
Nice to meet you.
And thank you for supporting our webinar. The Honorable, the first Vice Dean Faculty of Engineering and Informatics, Universitas PGRI Semarang, Bapak Asisten Profesor Ibnu Wisodo, and the Honorable, the second Vice Dean Faculty of Engineering and Informatics, Universitas PGRI Semarang, Assistant Professor Febrian Murti Dewanto, and he is also a speaker for this webinar. The Honorable Chair of International Webinar, Faculty of Engineering, Dr. Irna Farika, the Honorable Head of Department of Electrical Engineering, Mechanical Engineering, Food Technology, Civil Engineering, Architecture, Informatics, and all participants. Ladies and gentlemen, I believe that all of you have well done through the 6 series international webinar, Faculty of Engineering and Informatics, Universitas PGRI Semarang. It is my great pleasure that you had fruitful discussion. Today is the last series of our international webinar. We already accomplished 6 series. The first series is about advancement in revolutionary industry and accelerated research. The second series is cooling technology. The third series is electro spinning. And after that is accreditation for technologies in new normal era and also green building in new normal life. Finally, today is the last series that is multimedia interactive system. Alhamdulillah, this event is going well and participated by students, researchers, and lecturers in Indonesia and abroad. This event is collaboration between University Technology Malaysia, University Technology Mara Shah Alam Malaysia, and Universitas PGRI Semarang. Before I close this international webinar, I would like to take opportunity to express my appreciation to Professor Ali Slamet, Dean of Malaysia Japan International Institute of Technology, University of Technology Malaysia, and also thank to University Technology Mara Shah Alam Malaysia for become the speakers in our webinar, and also all speakers from Faculty of Engineering and Informatics, Universitas PGRI Semarang. Hopefully, in the future, we can do another collaboration in research, student exchange, and so on. Moreover, I would like to thank to the committee who organized the webinar well, and also all the participants. Hope we can continue for another academic webinar. Finally, I would like to close my remark and officially announce the end of the webinar. Wishing the good future for the science and engineering. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak Slamet. You have for delivering closing speech and officially close the webinar series. Before we end this webinar series, let us take a photo session. I request to all of the participants to turn the camera, to turn on the camera, so that we can get a good picture. Please perform your best. Okay, I will capture this. Okay, I'll take first. 1, 2, 3. Okay, slide 1, slide 2, 1, 2, 3. Okay. Okay, thank you. Great. We have reached the end of this webinar. Me, myself, and all of the committee, thank you for your very kind attention and cooperation. We hope to see you in the next time. Thank you and see you.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Thank you, Professor. Yes, rampung kabeh. Hah? Ibu guru bahasa Inggris. Ijo. Ibu kan guru bahasa Inggris nang SMA piro ya.
Terima kasih Pak Dekan, Pak Kaprodi, panitia, Bu Nora.
Terima kasih kepada semuanya, panitia, Bu Irna, Bu Mega ini yang supporting us.
Pak Agung. Ya, di rumah Pak.
Pak De Agung ini.
Iya, ada Pak Agung juga nih Pak.
Terima kasih ini para mahasiswa juga ini Mbak Mona dan her geng. Terima kasih juga Pak Agung Teknik Sipil ini eksis terus, lalu hadir. Pak Agung Han, Pak Beng juga ini masih stay di sini. Oke, selamat kepada semuanya. Alhamdulillah ini sudah selesai semuanya. Mudah-mudahan kita ke depan punya acara lagi, punya sesi lagi yang lebih meriah lagi begitu, karena apapun harus selalu meningkat begitu. Dan tadi Bu Mega sudah mancing-mancing ini untuk sense kelima ini. Nah, segera disiapkan.
Ya Pak,
ini.
ditunggu Pak.
Ya, iya, segera disiapkan.
Padahal saya cuma bilang tes loh Pak awalnya.
Ya, nanti biar sama Pak Badek satu itu, Pak Ibnu itu yang.
Oke.
Oke, segera saja. Paling enggak sebelum Desember ini ya sudah bisa terlaksana ya. Kalau tahun lalu kan Desember ya. Oke. Oke,
Ini
ya,
Pak Budi Irwan Asri, Pak Budi terima kasih.
Ya,
Pak Budi ikut terus ini Pak dari seri 1 sepertinya.
Ya, terima kasih Pak Budi. Sukses Pak.
Nah, ini Pak Kaprodi dan Pak Wadik juga.
Jejera atau kue?
Yang belum mengisi link absensi, silahkan diisi.
Yang di?
Ini Pak di chat room Pak, ada Pak. Sudah ketemu Pak?
Ya.
Ya, silahkan diisi Bapak Ibu yang belum mengisi absensi. Bu Indri, gimana kabarnya Bu Indri?